DMR, ladies and gents, today is your last day of practice before your quiz tomorrow. Okay, so on your quiz today, treat it like it's a real graded quiz and see how you're going to do. Questions that you get right, celebrate. Questions that you get wrong, study. Do some more practice. See if you can figure out why. Open up your trusty dusty math notebook. Look at your definitions. Here we go. Mrs. Sharp drives us to school using both the highway and side roads. I didn't mean to say us, I meant to say using. She drives herself using those. If she travels 4/6 of the way to school on the highway, what fraction of her trip is on the side roads? Well, if I draw a road here and I divide it into 6, there's half. There's 3 on that side. There's 3 on that side. And 4/6 of it is on the highway. Highway, 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 highway. What fraction of a trip is on the side roads? That only leaves 2 pieces left for side roads. So that would be 2 of the 6 parts. So 2/6 of her road trip is on side roads. Questions on that one?
Love you.
Alrighty, let's continue on.
Come on, door.
Next question 3. Use the less than, greater than, or equal to compare the numbers. 703, 730. Both of these have 7s in the hundreds place, so we've got to go look at the 10s. 0 tens and 3 tens. 3 tens is greater than 0 tens, so this will read 703 is less than 730. Should have selected the first symbol. Next up, look at the fractions below. Choose all that is true about this fraction. Notice that all says 3 points, so we are going to select 3 answers. 1/8. This is a unit fraction. Correctamundo. Unit fractions are 1 part of a whole, and 1/8 is 1 part of a whole with 8 pieces. There are 8 pieces in this whole. Correct. Okay, in this whole is the denominator. The denominator is 8, so there are 8 in them. This is more than 1/2. Wah, wah. We know that half of 8 is 4. It takes 8 of these to make a whole. That is true. I have 8 1/8 inside of a whole that has 8 parts. There they are. Well, that's really ugly 8, but you get the point. This is equal to 1/2. No, because we know that 4 is 1/2 of 8. So there we go. Questions, concerns, comments? Alrighty then. Type the missing number that makes the equation true. 9 times something equals 45. I don't have a 9s song, but I do have a 9s finger trick. I have groups of 9 that I can draw and count as I go, or I can have the fact memorized and know that it's 9 times 5 equals 45. If I want to use my finger trick, I can go like this. 1, 2, 3, 4, 5, and put the 5th one down. There are 4 10s. There are 5 1s. 45. So 9 times 5 is equal to 45. Compute to find the answer. 36 divided by 9. Again, I could use my 9s trick until I get 3 10s and 6 1s. 1, 2, 3, 4. 3 10s, 6 1s. That was my 4th finger. Or I could draw some 9 groups. 5 groups, 6 groups, 7 groups, 8 groups, 9 groups. And I could put 1 item in each group until I get to 36. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. There are 4 in each group. Questions on that one? Aiden Hampton.
I didn't mean to put my hand up.
No problem. All righty, there we go. Your DMR has been reviewed. All right, yos. Time to get on to our graphing, okay? On that seesaw, click on that light bulb. The lesson is titled Lesson 7-4, Solve Real World Problems Using Information in Graphs. Solve real world problems using information in graphs. It says with your teacher, we're going to watch some teaching videos on slides 1 through 4. We are going to complete slide 5 with your teacher. You are going to complete slides 6 and 7 in your breakout rooms and be ready to share what you did. Justin is sharing what he's doing right now. But it's not math lessons, so he shouldn't be sharing it. I love you so much. Thanks for letting me see your face. All right, here we go. Let's continue on. Solve lesson 7-4. He gives me a thumbs up. I give you a thumbs up, sir. All right, here we go. Add response. All right, warm it up, warm it up, warm it up. The students in Mrs. Seymour's class voted for their favorite kinds of sandwich. How many more students voted for peanut butter than cheese? What? There's a second question. Huh? Let's answer the first one first. How many more students voted for peanut butter than cheese? All right, let's figure this out. Peanut butter, we got it right here. Thank you, George Washington Carver, for peanut butter. I got my peanut butter right here too. Look, it's peanut butter. All right, got our peanut butter. We're gonna look at our graph. Our graph is counting by 2s. Check out our scale. 2, 4, 6, 8, 10. Look at peanut butter. It's in the middle of 10 and 12. What's in the middle of 10 and 12, y'all? 11. You're so smart. 11. 11 people voted for peanut butter. How many people voted for cheese? Let's check it out. Here is our cheese. Look, cheese is over here. It's in the middle of 6 and 8. What comes in between 6 and 8, y'all? You're right. It's 7. So we're going to subtract 11 minus 7. We are subtracting because it says how many more than. It does not say how many altogether. It does not say how many people voted for peanut butter and cheese. It says vote how many more voted for peanut butter than cheese. So we are going to subtract. 11, take away 7. Miss Sousa, this is so easy. You're right, but I'm checking your reading graphs, not your subtraction. 11, 10, 9, 8, 7, 6, 5, 4. 4 students. Boom. 4 students voted for peanut butter than cheese. 4 more. All right, now that you're warmed up, you're gonna do this next one on your own. You ready? Check it out. It says, how many fewer is a subtraction word, students voted for tuna than peanut butter? Go solve it. I'm not gonna do it. You're gonna do it. Go solve it. You are looking at peanut butter. You already know that that's 11. And tuna, you're going to figure it out. How many fewer students voted for tuna than peanut butter? I'm going to look at your screens and I'll stop talking so that you can work. And then when I see your work is done, we'll come together. Josh, you're on like slide 1,000,000. We're on slide 1. How are you going to show me you're solving that problem if you don't have it? Sinq's got the subtraction problem down. Aiden Hampton is writing it right now. Aiden G is zooming in on that graph to get a better view. Super smart. Good. I am seeing our subtraction problem so far. 11 folks voted for peanut butter. We're subtracting tuna. Only 3 people voted for tuna. 11 subtract 3 is your equation. 11 subtract 3. Y'all are scaring me. Some of y'all got the wrong answer. Some of y'all are telling me 11 subtract 3 is 7. Check your math. 11 subtract 3 is 11. 10, 9, 8. 8 students. 8 students fewer voted for tuna than peanut butter. Questions on how we solved those? Alrighty then. Let's continue on to our learning goal. Our learning goal for today is...
Here is our learning goal for today. Today, we are going to continue being able to solve one-step problems and add in two-step problems with the words how many more and how many less or fewer using data from a graph. Also, another skill you need to be able to do is to be able to correctly read a bar graph with a scale greater than 1.
All right, there's our goal. Let's take a look. We have a lovely example. That example is here. And guess what, guys? My play button didn't want to work again, but then I figured it out. When I click this link, I don't have a play button, but when I load it myself, I have a play button. So now I know. So this is a paper example of what you are getting ready to see in the video. Ms. Sousa, why do you give us a paper example? Thank you for asking. I give you a paper example so that when you are working independently, you can come back and see it step by step, okay? Let's take a look at your example today.
How can you solve problems using graphs? Think about this problem during the lesson. Angela wants Carly and Monique to have a total of 60 paper cranes. The bar graph shows how many paper cranes her friends already have. How many more paper cranes does Angela need to make in order for Carly and Monique to have 60 paper cranes in all? 4 girls and their work are represented by this graph. From the graph, how do you know who has the most paper cranes and who has the fewest? Carly's bar is the longest, so she has the most paper cranes. Monique's bar is the shortest, so she has the fewest paper cranes. This problem has a hidden question, and you need to find it and answer it. What is this hidden question that needs to be answered before the main question can be answered?
So here is our problem. Our problem is how many total paper cranes Carly and Monique have already made in order to know how many more paper cranes Angela needs to make so that Carly and Monique can have a total combo of 60. Okay, so we have to figure out, first of all, how many the 2 girls made together before we can figure out how many more they need. So this is a 2-step equation. We'll add the girls together, then we'll subtract that total from our 60.
How many paper cranes have Carly and Monique already made? You need to know how many total paper cranes Carly and Monique have already made in order to know how many more paper cranes Angela needs to make so that Carly and Monique can have a combined total of 60. Use the scale to find out how many paper cranes Carly and Monique have each made. What is the scale used in this bar graph?
William, what's the scale used in this bar graph?
5.
Fives. We're using fives. We're using fives. Oscar, how did William know that we're using fives?
Because it says right there.
What does it say?
5, 10, 15, 20, 25, 30.
Booyah, Oscar recognized that skip counting. When we are skip counting by a number, that is an indication that that is the scale that we are going to be using, Justin. The scale that we are going to be using, Justin, is a 5. No, Justin, not 3. You're holding up 3 fingers. It's 5. Justin, it's 5. All 5 fingers. Justin, it's 5. Justin, it's 5. Good job. Okay, here we go.
The scale used in this bar graph is 5, so each grid line represents 5 paper cranes. Carly has 30 paper cranes, and Monique has 10 paper cranes. Which equation shows how many total paper cranes Carly and Monique have made?
Select your answer.
All right, if we're finding a total of how many Carly and Monique have made, A and G, does that word and tell us to add or subtract if we want to know what they have both made?
We're going to add.
Booyah! Thank you, sir.
Add to find this total. 30 plus 10 equals 40. Together, Carly and Monique have made 40 paper cranes.
Remember, you still need to answer the main question.
Thank you, tiny dude.
Can you answer the main question? Which equation shows how many paper cranes Angela needs to make in order for Carly and Monique to have a combined total of 60 paper cranes?
All right, they've made 40.
Select your answer.
We got to get to 60. We want 60 paper cranes. So, by a show of covering your camera, if you think the equation is 60 minus 40, cover your camera. All right. If you think the equation is 60 plus 40, cover your camera. I am so glad that the majority of my class didn't participate. That was like 5 of you. Let's try it again. If you think the answer is 60 minus 40, cover your camera. If you think the answer is 60 plus 40, cover your camera. All right, now y'all are being silly because some of y'all covered your camera for both of them. How are you going to add and subtract? The correct answer here is 60 subtract 40. Guys, take a look at this. It says that we need 60 paper cranes. If we need 60, why in the world would we add to 60? We only need 60. Why would we add more to that? No. The problem says we need 60. So we need 60. We have 40. So we're subtracting the 40 we have to find out how many are left. 60 minus 40.
So why did you do A or B? That's why I did this.
To answer the main question, subtract the number of cranes that Carly and Monique already have from the total number of cranes that Angela wants them to have. 60 minus 40 equals 20. Why do you need to subtract to find the answer? You need to subtract to find the difference between the combined number of paper cranes that Carly and Monique already have and the total number of cranes that Angela wants them to have. Angela needs to make 20 paper cranes in order for Carly and Monique to have a combined total of 60 paper cranes. Now you know how to solve problems using graphs.
I'm so glad that that little dude was there to go. All right. I want to point something out to you guys. Take a look down here. 3 minutes, 34 seconds. The textbook company took 3 minutes and 34 seconds to solve this equation. Okay, we took longer. That tells me that when you are getting these problems done like this, you made mistakes. Okay, the professional company just took 3 minutes and 34 seconds to solve one problem. It's going to take thinking power and time to get these correct. Okay, so don't feel frustrated when it's taking you time. The professionals take time too. All right, this is on purpose. All right, let's take a look at slide 4. This is an example that you have to look at before I release you to work in some breakout rooms.
Have a discussion with your class. How does a bar graph help you to compare data?
Dun, 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 dun. How does a bar graph help you to see data, 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 data? Steve, help me out. How does a bar graph help us see data?
It shows it by raising up the numbers, and then and where they are on the bar graph is how much they have.
Nice. I like the way that you said it raises up the numbers. So those bars get higher. If the number or the amount of data is getting higher, the bar is raising up, in Steve's words. Thank you, Steve. So we in our heads can see numbers and we would have to go, okay, 30, that's bigger than this one, but that's smaller than, and that's a lot to hold on to. A bar graph makes a pretty picture for us. It lets us see it right in front of our face, like, oh, Rosita has the most. I don't even know how much Rosita has yet, but I know she has the most. Okay, look here. Hal and Victor are tied. I don't even know how much Hal and Victor have yet, but I know that they're tied. So it gives us quicker access to that information.
What I notice is that by having a bar graph, I can quickly tell and see which one has the most and which one has the least. I can also tell that this one is more than this one is more than this, and that these two are the same because they fall on the same line. So this bar graph helps me quickly notice greater than and less than and equal to. First, I'm going to use the scale to record how many miles each person rode. When I look here at my graph, I notice that it's counting by tens, 0, 10, 20, 30, 40. So my scale is going to be 10. Now that I know my scale, I can easily find how many miles each person rode and record that in these boxes. Victor here goes up to this line, and that is 20. So he rode 20 miles. Rosita, I can count up 10, 20, 30. Oh no, she only went halfway. I know that half of 10 is 5, so I'm going to stop at 30 and add 5 more, which makes 35 miles. When I look at Gary, he falls right on a line. It's this line right here at the top of the orange bar, and that's at 30. And I remember that earlier, I already noticed that Victor and Hal, these two were the same. So if Victor was 20, Hal is also going to have 20 miles. My question over here is a two-step question. How many more miles did Hal and Victor ride than Rosita? So this is 2 people compared to 1 person. So my first step, I'm going to gather all of my information in one place. Hal and Victor, and then Rosita. Hal rode 20. Victor also rode 20. 20 plus 20 is 40. Rosita is by herself, and she rode 35 miles. For step 2, I need to come back to the question and I need to figure out how many more miles. So it's Hal and Victor, then Rosita. So I'm going to do Hal and Victor minus Rosita, because I know that how many more means that I'm going to subtract. So I know that Hal and Victor rode 5 more miles
I saw you, Justin. Good man.
than Rosita.
All right, let's take a look at that. Look here. Look at her time, 3 minutes and 36 seconds. So the textbook took 3 minutes and 30 seconds. The professional company, the teachers took 3 minutes and 36 seconds. So should you guys get done in 5 seconds?
No.
Thank you, Terrence. No, you should not. You should be taking your time. These problems require a lot of thought, okay? A lot of steps and a lot of information gathering. So we're going to practice one. And I want you to notice it is 10:58. You see that? 10:58. Let's see how long it takes us together as a class. Ready? Here we go. Use the scale to record how many t-shirts were sold. I'm writing, you're writing. Here we go. The scale shows me that 1 t-shirt is equal to 10 shirts. Half of a t-shirt is equal to 5 shirts. Okay, so I'm counting by 10s and 5s. Here we go. How many blue shirts were sold? Well, blue at Jazzy's is 10, 20 plus 5, that's 25. Let's add that in. I'm typing, you're typing. If you double click on those pink boxes, it will let you type inside of them. All right. How many red shirts were sold? Say that 5 times fast. At Jazzy's shirt store. Well, there are 2 full t-shirts. That is 10, 20. 20 red shirts at Jazzy's. How many green t-shirts at Jazzy's? At Jazzy's, there's only 1 half t-shirt. A half t-shirt represents 5 shirts. So there were only 5 green t-shirts sold at Jazzy's. Let's check out t-shirt sales at the Ultimate Tee. Blue t-shirts at the Ultimate Tee. There is 1 full t-shirt. My scale told me that 1 full t-shirt equals 10 shirts. 10 blue shirts were sold. Red t-shirts here. I have 10, 20 plus a half shirt, which is 5. So 25 red t-shirts were sold. And then let's take a look at the green shirts at the Ultimate Tee shirt shop. Green is 10, 20, 30. 3 full t-shirts. That means we count by 10 3 times. 30 t-shirts. Oh my gosh, it is already 11:01 and we haven't even finished yet. We've been at it for 2 minutes and 57 seconds. Let's keep going. How many more red t-shirts, that's important, red t-shirts were sold at Ultimate Tee than at Jazzy's? So I'm looking at the red shirts at Jazzy's and Ultimate Tee. So I'm going to look at this middle row here. Okay. How many more red t-shirts were sold at Ultimate Tee than at Jazzy's? I can add or subtract in this instance. I'm going to record my information. At Jazzy's, there were 20 shirts. At Ultimate Tees, there were 25 shirts. I know that 25 is 5 more than 20, so I could add that up. 20, 21, 22, 23, 24, 25. I could also set it up as subtraction. 25 minus 20 equals 5. Either way, there were 5 more. And guess what I can't do? I can't just say t-shirts, because all of these are t-shirts. Our question is about red t-shirts. So 5 more red t-shirts at Ultimate T, I'm going to put a U-T, than Jazzy's. I can't just say t-shirts because there are blue t-shirts, red t-shirts, green t-shirts. And I can't just say red t-shirts because then I don't know if you're talking about Jazzy's or Ultimate Tees. So we've got to be specific about which t-shirts we are talking about here. And done. 11:03:24. That took us as a class on Seesaw about 4 minutes and 30 seconds. Okay, so it took the professional textbook company 3 minutes and 36 seconds. It took Miss Sharp's example 3 minutes and 30 seconds. It took us 4 minutes and 30 seconds. These problems take time. If they take time, you are most likely doing them correctly. If you are done super fast, you most likely failed, because you didn't think about all the parts, okay? So with that in mind, you are getting ready to go into breakout rooms to solve the next 2 slides. There are 2 slides. It's taken us about 3 to 4 minutes to solve 1 slide. So I'm going to give you about 9 minutes in your breakout rooms to solve these 2 problems, okay? You in your breakout room are going to solve the slides that say in your breakout room. Slide 6 says breakout room. Slide 7 says breakout room. Okay? Slide 6, slide 7. That's what you're going to do. Now, I want to point out that you're working with the same graph that we just used. Work smarter, people, not harder. Don't waste time going back here and counting all these again. You already have that information right here. Okay? Work smart here. Use what you know to solve what you don't know. Okay? All right.
In progress. Definitely not.
Thank you, Aiden Hampton, for the support. I appreciate it. All right, here we go. How many fewer green t-shirts were sold at Jazzy's than at Ultimate Tee? Slide 6. This is the answer that you and your partner should have, I wanted to say earned, should have come to, arrived at. There we go. You could have used addition or subtraction. I chose subtraction. My green t-shirts from Jazzy's totaled 5. My green t-shirts from Ultimate Tee totaled 30. 30 subtract 5, Justin, leaves me with 25 t-shirts. 25 of them. Okay? Notice my label down here does not just say 25 t-shirts. The question gives me my label. Fewer, look at my label, fewer. Green t-shirts, green t-shirts. Sold at Jazzy's, sold at Jazzy's. Than at Ultimate Tee, than at Ultimate Tee. My label matches my question, okay? Label matches my question. Any questions on slide 6? All right, let's take a look at slide 7. Here's where your heavy lifting came in, okay? Slide 7 says, how many more blue and red t-shirts were sold at Jazzy's than green t-shirts sold at Ultimate Tees? So I went ahead first of all and I circled the information that I needed. so that I didn't accidentally count the wrong section. Blue and red at Jazzy's totaled 25 plus 20. That gave me 45 blue and red t-shirts at Jazzy's. My green t-shirts from Ultimate Tee were a bit more straightforward because it's just one to count, and that was 30. I again used subtraction to compare these. 45 blue and red from Jazzy's, subtract the 30 from Ultimate Tee, left me 15 t-shirts. Let's talk about this label again. Notice my question. How many more blue and red t-shirts? Look at my label, blue and red t-shirts. Were sold at Jazzy's. Look at my label, sold at Jazzy's. Then green t-shirts. Look at my label, green t-shirts. At Ultimate Tee, look at my label, Ultimate Tee. Your labels should match the questions. If you just say t-shirts, I don't know which of all of these shirts you're talking about. Okay, so we've got to get specific with those labels in there. Questions on slide 7. Aiden Hampton.
I was going to ask you to go back to slide 6.
Sure thing. Question on it, or you just need to see it?
I need to see it.
All righty. Okay. Your independent work today is to complete the remainder of these slides. Slides 8, 9, 10, and 11 are work slides. On slide 12, there is a link to a game, a graphing game that we would like for you to play. On slide 13, as always, is your success criteria. Review, let me know how you're feeling, use math vocabulary. I am going to be taking a small grade on this so far. I have not graded anything on graphing yet, but we've now practiced for 4 days. So I want to get an official posting of where you are, okay? So take your time to answer each of these questions. Remember, guys, there's a nice little video on each slide that can help you out too. So you've got a little bit of a hint here. Each slide has a video reading it to you and giving you hints.
Daryl made
Okay.
a
All right, that is your work for today.